Morning to all of us. Now we present the topic of arches. So, arches topic is covered to the three-hinged arches, general flow, parabolic arches, circular arches, practical problems. So, this topic is covered to this section. So, first of all, arches definitions. So, what is meant by arches? Arches is a curved structures or humbled beam. Primarily, they pure the applied loads by compression. So, the hinge introduced anywhere in the arch match the structures determined as first one is both supports are assumed to be hinged and then hinge introduced to the arches provides a further equation analyzed to the arches. That is a moment of all forces about hinges is equal to zero. This is the introduction of the arches. Um, so next one is so first of all, arch is a curved structures or hummed beam with the applied to the load by compression. So first conditions is both supports are assumed to be hinged. So second one is hinged introduced the arches provide the further equation analyzed to the structures. So moment of all forces about hinges is uh, equal to zero. Okay. So normally the third hinges is introduced at the topmost point on the arch curve known as crown. So this point is crown, hinge at crown. So this height is YC rise. So A and B distance of the length of the span. So this is the parabolic arch. So first hinge, this is a second hinge. So center point is a hinge formed to the hinge introduced to the ground. Next one is one can solve the arches as B if we know the horizontal reaction at the various supports. With the help of the third hinge, we can easily determine the horizontal reaction and hence arch can be analyzed. So arches formulas follow to the next slide. So consider on arches A, C, B hinged at A, B and C. L is the horizontal span and Y is central rise. So this is a sonnet figure. Mm, see the figure. So A, C, B arches hinged at A and B and C. L is the horizontal span and Y C. This is a central rise. So arches formulas. So obtain the vertical reaction VA and VB at the ends of the as usual to find the horizontal thrust. Moment at C or the moment at the central hinge must be zero. So general derivations to find the H, the horizontal thrust moment at C, the moment MC, the moment of the at the central hinge C must be no. So MC equal to mu Z plus HYZ equal to zero. So horizontal thrust H equal to minus mu c divided by yc. This is first equation. Second one is we can find the moment at any cross section x of the arch whose coordinates are x and y. Mx equal to mu x plus h into y. So this is the second equation. Sir. So next one is the vertical and the horizontal action of the section considering the portion of AX arc. So vertical reaction can be found out by vertical shear at the section as a side horizontal beam. V equal to VA minus W1 minus W2. So this is the vertical reaction and find out the vertical force. So horizontal thrust at both ends is same. So H equal to H. So this is formed to the A pointers is A to C or A is formed to the theta, the horizontal force and the vertical force, W1 and W2. This rise is Y, central rise is YC. Uh, the X is the distance of the distance of X formed to the Y. So P equal to H cos theta plus V sin theta. So F force is F equal to H sin theta minus V cos theta. So next one is draw the tangent at X to the center line of the arch and let it incline to the horizontal must be theta. So P equal to H cos theta plus V sin theta. So force F equal to H sin theta minus V cos theta. So resolving the V and H normally to the sectional and tangentially along the tangent at X. So T equal to V squared root of v squared plus h squared or root of t squared plus f squared. So the resultant t is required to the equation 5, use of the equation 5. So first one is parabolic arch. If the parabolic arch is 3 hinge arch is parabolic, if in shape and if it carries a uniformly distributed load over the entire span. Every action of the arch will be pure in compression. Resting only, next one is resting only a normal thrust. Next one is there is will be no shear force nor bending moment at this section. So parabolic arches, linear arches. So the linear arches for a given load system on an arch represent the view diagram. With a uniformly distributed load over the entire span, the new diagram is a parabola. The linear arch, which is parabolic, will then have 3 points at the hinges in common with the center line of the actual arch, which is also parabolic. Mm, um, Linear arches will there be identical with the actual arch. To obtain the bending moment, it will be necessary to calculate the rise at any section of the arches. So next one is any other loading on parabolic arches, that will be three straining action P, F, and M at the any section. So y equal to lambda x into L minus x. So lambda means constant, x equal to L by 2, y equal to yc. So yc equal to lambda into L by 2, L minus L by 2 means L by 2. So lambda equal to 4yc divided by L squared. So substitute the values of lambda. So y equal to 4yc divided by L squared, x into L minus x. So it may be also be noted that the quarter points were x equal to L by 4. The rise is 3 by 4 yc. The values of dy by dx equal to tan theta. So 4 yc divided by L squared. So x into Lx, differentiate the different with respect to x. So find out the L. Um, Next one is a minus x into x, x square. So x square with the difference of the equation with respect to x. So x square differentiate 2x. So substitute the values L minus 2x. So dy by dx the tan theta equal to 4yc divided by L squared into L minus 2x. So next one is parabolic arches. So this is parabolic arches, A and B arches. So this is the radius. This one is radius, this one is radius, and this is central point of O. So the central rise is YC. This vertical and horizontal, vertical horizontal distance is x, vertical distance is y. This is theta and the alpha. And this is formed to the circular arches. So center line of the arches is segment of a circular radius, or it's more convenient to have the origin at D, the middle of the span. Let x comma y be the coordinates of this section. So next one is AO and OB. So this is AO and OB is arch radius equal to radius, or AD and DB equal to L by 2, DC equal to YC. So OY equal to OD plus DY. So OD means capital R minus YC. So dy is plus y. So xy is equal to x. So x squared equal to OY squared plus x squared. R squared equal to x squared into R minus YC plus y whole square. So yc into 2r minus yc equal to L squared divided by 4. So sin alpha equal to AD divided by AO. So AD means L, AO equal to R2R. So cos alpha equal to OD divided by AO. So OD means R minus YC divided by R. So x equal to OX sin theta, R sin theta. Y equal to OY minus OD equal to R cos theta minus R cos alpha. So that is R is common. So R into cos theta minus cos alpha. So example sums. A three-hinged parabolic arch at the ground and the springs has a horizontal span of 48 feet. It carries a UL of 75 ton per feet. Run over the left hand half of the span. Rise 10 feet. Calculate the reaction, normal thrust, shear force at bedding at 6, 12, and 30 feet from the left hinge. This is the length of the span, 48 feet. The central rise YC equal to 10 feet. So UDL load is above the span 0.75 ton per feet. This is the parabolic arches. So find out the reactions, normal thrust, and the shear force at bending moment of the section 6, 12, 30 feet from the left hand edge. So VA equal to, so normally first moment about A equal to 0. So VB into total distance 48 feet and minus load into distance divided by 2. So 0.75 into 28 into 24 into 24 divided by 2. So find out the value of VP. So VP equal to 4.510. So next one is vertical force is equal to 0. So vertical force VA plus VB equal to 0.75 into 24. So find out the values of VA equal to 13.510. So horizontal moment thrust is horizontal thrust H is moment about C equal to 0. So this point is I take the values, taken the values of 3 points. So VP into 24 minus H into YC equal to 0. So find out the H is 10.8 ton. So Y equal to parabolic equation Y equal to try to by 288x into 48x 48 minus x. Theta equal to 5 divided by 288 into 48 minus 2x, L minus 2x, L minus x. So find the values of x equal to 6, 12, 30. So y equal to 4 point, substitute the values of x equal to 6, y equal to 5 divided by 288 into x into 48 minus x. To substitute the values of x equal to 0. So find out the values of y, 4.375. So similarly, the theta equal to theta, find out the values of theta. So x equal to 0. Those are 6 feet is substitute the values 32 degree. And then 12 x equal to 12 meter. Substitute the values of x and find out the values of 7.5. So similarly, the theta equal to 22 degree 37 minutes. So x equal to 30 meter. Find out the values of y equal to 9.66 and theta equal to 11 degree 46 minutes. So cos theta values 0.848 and 0.9323, 9.739 is 979. Sin theta equal to 0.529, 0.348, 0.203. So moment is minus 20.25, minus 27, 20.25. So vertical is 9, 4.5, 4.5. So force is P equal to 13.93, 11.7, 9.49. So force F equal to 4.1.491, 2.2. So next one is example sum circular arches. The circular arches of span 80 feet with a central rise 16 feet. 16 feet. It's a hinged at the ground and supports carries a point loads of 10 tons 20 feet from the left support. So find out the values of reaction, normal thrust, maximum and the minimum petite matter. So this is the circular arches. So find out the values. Already find out the vertical reaction P and BP. Horizontal thrust H is find out. So Y is changed to the parabolic arches and circular arches. So already Y equal to 4y c divided by L squared x into L minus x. And for the parabolic equations. So circular arches is YC into 2r minus YC equal to L squared divided by 4. So R means it is r equal to r square equal to r x square plus y plus r minus yc whole square. So this is the central circular arches. So this is the three-hinged open circular arches examples of bridges. So in the figure, below there has a parabolic shape and supports uniformly loads. So the parabolic arches subject to only to axial compression at interdeterminated points D along its axis. The assumed loads is uniformly transmitted to the arches regard. So overall UDL of over the entire span of the UDL 7 per meter. So both it is hinged. So find out the values of moment reactions E and B, and find out the moment and forces, find out the rig of the force, and this also is a segment to the tan theta equal to by dx. So finally the values of ND, VD, MD, so find out the values of a segment of the BD. So a section of the arches taken to the through the points D and dx equal to L minus 7.5x by meter, y equal to 7 minus 7.5 into 7.5 squared into divided by 15 squared equal to find out the values of minus 1.875 meter. So the final values of the slope of the segment of the segment t equal t is 10 theta equal to d by dx minus 15 divided by 15 squared into x x equal to 7.5 meter. You substitute the values minus 0.5 theta equal to 26.62. So the finally values normal thrust under reaction vertical reaction V and VP, the horizontal thrust H. So normal thrust under reaction thrust find out the values vertical thrust, find out the values of ND and VD. So final moment is MD equal to 0 kilonewton. This is the examples of the parabolic arches and the circular arches. Thank you.